Chapter 15, Energy and its Forms, page 446 and 447. The road that winds through the mountain valley was closed. Skiers were banned from the area. The sound of artillery fire echoed from the mountains. It seemed out of place in this picturesque scene of snow-covered peaks surrounding the valley. A moment of quiet followed the blast. Suddenly, the snow broke loose with a menacing roar. Tumbling down the mountainside, the snow buried everything in its path. You can see in Figure 1 the enormous mass of accumulated snow that had hung above the valley. After the avalanche, the valley was quiet again. It is safe for skiers and hikers to return to the area. This is the work of researchers at the Avalanche Control Section in Glacier National Park, Canada. These scientists monitor the snow as it builds up layer by layer on the park's upper peaks. They can predict when an avalanche is about to happen. With well-timed artillery shots, they make the avalanche happen at a time when the released energy cannot harm anyone. Energy and work. Where did the energy of the avalanche come from? Where did it go? Energy is known by the changes it causes. You can hear the roar of an avalanche and see the movement of the snow. Sound and motion are examples of energy in action. In order to define energy, you need to return to the definition of a related topic, work. Recall that work is done when a force moves an object through a distance. Energy is the ability to do work. In other words, energy is transferred by a force moving an object through a distance. Work and energy are closely related. When work is done on an object, energy is transferred to that object. Work is the transfer of energy. And that's a key term, so I'll read it again. Work is a transfer of energy. Both work and energy are typically measured in joules, or J. Recall that 1 joule equals 1 Newton meter, the work done when an object is moved 1 meter by a 1 Newton force. Although energy can take many different forms, it can always be measured in joules. Think about the work and energy involved in doing something as simple as carrying your backpack up a flight of stairs. You do work on the backpack by lifting it against the force of gravity. This work requires energy. The energy to do the work comes from your muscles. Your muscles receive energy from the food you eat. The energy contained in your food comes from plants that have used the energy of sunlight or animals that have eaten such plants. Kinetic energy. Many forms of energy can be classified into 2 general types, kinetic energy and potential energy. The energy of motion is called kinetic energy. The word kinetic comes from the Greek word kinetos, meaning moving. The kinetic energy of any moving object depends on its mass and speed. To calculate the kinetic energy of an object in joules, multiply 1/2 by the object's mass in kilograms and the square of its speed in meters per second. Notice that doubling the mass in the formula would double the kinetic energy. However, doubling the speed would quadruple the kinetic energy, since kinetic energy is proportional to the square of an object's speed. And again, the formula for kinetic energy is kinetic energy equals 1/2 mass times velocity squared.